So in slope-intercept form, these are what those variables stand for. M is the slope, B is the y-intercept, x is all the x coordinates that's going to make this equation true, and b is all the, or y is all the y coordinates that are going to make the equation true. It's all the coordinates that this line lies on. If it doesn't lie on this line, it's not part of the solution. It doesn't make this true. Okay, so we're going to look at some examples of that. Any questions what the variables stand for? Again, you only need these two things in order to be able to graph it. You need a y-intercept, find out where it goes through the y-axis. You need a slope to figure out how much to go up, down, left, or right. All right, then we had kind of four main steps to graphing a linear equation, to graphing a straight line. This is the next thing on your note sheet. The first thing is to put the equation in slope-intercept form. Intercept form if necessary. Sometimes it's already in slope-intercept form for you, like the ones we just got done doing. Okay? Slope-intercept form again means you have the y by itself, you have the equal sign, then you have the m and the x together, and then you have the plus or minus b. So the first step is we always want to graph in slope-intercept form. Put in that first. That's going to be the easiest thing to do. Second step is we're going to plot the y-intercept. We're going to find out where does that graph cross the y-axis, and we're going to plot that point. After it's in slope-intercept form, it's really easy to tell what the y-intercept is. The third step is to use the slope to plot more points. Once you have the y-intercept, you can use the slope to go up, down, left, or right to plot another point so that you can draw a line. If you want to be really sure, you can plot a few more points. And the last step is to connect with the straight line with arrows on the end. Again, the reason we put arrows on the end is because these lines go on forever. Technically, there are an infinite amount of x's and y's that make it true. Okay? We just connect our points with a straight line. We draw arrows on the end. So these are the same steps we follow every time we're trying to graph something. Okay, we're trying to graph a linear equation. Okay, here's example one. First step, is it in slope-intercept form? Yeah, y's by itself. We're good there. Step two, plot the y-intercept. What is the y-intercept of this graph? -5, right? It goes through the y-axis at -5, so let's plot that point. Okay. The y-axis at -5. What's the slope of this line? Or the rate? 2 over 1, right? It's not. It doesn't have a fraction, so I'll put it over 1 because the top number tells me how much go up or down. Bottom number tells me left or right. It's positive 2, so from here I'm going to go up 2 to the right 1. And you can do that a few times just to get a more accurate line. Okay? And then last step, you connect those with the straight line and draw arrows on the end. So this would be the graph of this equation. The reason this is useful is because now you can find what x things that make this equation true for x and y without having to do anything. For example, if I told you, does 1, 3, if you plug that in there, x is 1, y is 3, does it make this true? And without even doing any math, would 1, 3 make this true? If you plug in x is 1 and y is 3. That's this point right here. It would not. Because it's not part of this line. It's not a solution to it. But if I asked, does the point 3, 1, if you plug in x is 3, y is 1 here, that's this point. That would be true, right? Because you'd get 1 equals 2 times 3 minus 5. 1 equals 6 minus 5. 1 equals 1, so that's true, right? Every point on this line is a solution. There are an infinite amount of x and y solutions that make this true, which is why we have a line with arrows on the end. So every line on this makes this true. Every point off this line is false. Okay, so that's example 1. Try example 2 yourself first, and then we'll check it together. So first here in example 2, what's your y? Well, first, is it in slope-intercept form? Yeah, it is. Y is by itself, right? Good. Step 2, what's the y-intercept? 4 on the y-axis, so I'm going to plot that point. What's the slope? Negative 3/4, so is it going to be uphill or downhill? Downhill. So you can take this negative with either the numerator or the denominator, just not both. Because a negative over a negative would make it positive. So I can either go down 1, 2, 3, and to the right 4, or you could go up 3, which would be positive 3, and then to the left 4, which would be negative. Either way, or you can do both, you draw your line and put arrows on the end, so it should look like that. It's a downhill line. Okay. The negative can go either with the numerator or denominator, just not both. If it went with both, it'd be a negative divided by negative, which would make it positive. Okay. So that's the graph of that line. So again, without even doing any math, if I told you, is 2, 0 a solution to that equation? You would say yes or no. That's that point right there, right? Not a solution. If you plug in x is 2 and y is 0, that would not make this true, because that's it. But if you plugged in 4, 1 into that equation, that's this point, it would be true. That would make it true, that would make it false. Every point on this line would make that true. Every point not on that line would make it false. Any questions there? All right, example 3. So first, is it slope-intercept form? Yes. The y-intercept is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So for me, that's right there. Your graph, I think you're going to have to go 1 off the page. And then the slope is positive 1/7. So how much am I going up here? 1, and to the right 7. 1. And mine goes off the graph here. But it's going to be kind of a close to a flat line. Because we know a flat line has a slope of what? 0. And 1/7 is a small number. It's kind of close to 0. Okay? But the closer it is to 0, the flatter it's going to be. The farther it is from 0, the more straight up it's going to be. The steep it's going to be. Okay? Or you could go down 1 to the left 7. Either way. But it should be a pretty flat line, just slightly going uphill because it's positive. Question with that one? All right, we had 2 left. Next one. Now we can't start graphing this one yet because why? Not in slope-intercept form, right? Not in slope-intercept form, so we can't graph it yet. We have to put it in slope-intercept form. That's always step 1. That means we have to get it so that the y is by itself. Now, we're trying to solve for y. We want to get it by itself. It's a negative 3y right now. We could leave it right here, but I want to deal with positive y. So what's some way I could make this a positive 3y? Yeah, just move it to the other side, right? If you add 3y, that goes away. Add 3y there. Let's rewrite what that gives us. We'd be left with 4x on the left side, and we'd have 18 plus 3y on that side. Again, we can't add those together because they're not like terms, so we just leave it like that. The reason I did that because I now made the y positive. We never want to deal with negative y's when we're graphing. Now I'm trying to get this variable by itself, so what's going to be my next step here? Move the 18. Right. Subtract 18. Subtract 18. That goes away. Again, I can't subtract 4x and 18 because they're not like terms, so I'll just leave it like that. Equals 3y. And then our last step here is I need to undo that multiplication by 3. So I'm going to divide by 3, which is going to leave me with a 1 there. Now, you can either write that all divided by 3, or you could divide them individually by 3. I'm going to divide them individually by 3. That way I can simplify if necessary. So once I do that, can I simplify 4/3 x anymore? Nope. I'm going to leave that. I don't want a decimal because I don't know how to graph decimals when they're slopes. Minus 18 over 3, 6 equals y. So this would be what I have to graph now. That's in slope-intercept form, even though the y is on the right side of the equal sign. I just need to get the y by itself. What's my y-intercept there? -6, the number without the variable, right? The number without the variable is the y-intercept. So I'm going to go to -6, which for me is right there. What's my slope? 4/3, right? Both positive. So up, 1, 2, 3, 4. To the right, 1, 2, 3. Again, you only need connect those 2 points with a straight line, and it would look like that. Once you get it in slope-intercept form, it's very simple to graph. Y-intercept, slope. Y-intercept, slope. But sometimes you have to do a little work to put it slope-intercept form. Can't start graphing this one because it's not slope-intercept form, so I need to get the y by itself. It's already a positive 7y, so I'm not going to move it to the other side. I'm just going to start getting it by itself, which means what do I have to move over first? The 21. You always undo addition or subtraction first when it doesn't affect everything. You could divide everything by 7 to start with. I'm going to wait until the end to divide everything by 7, though. You could, yeah. So that goes away. So I'm left with x plus 21 on this side equals 7y on that side. Now I want to get y by itself. So I'm going to undo the multiplication by 7. I'm going to divide by 7. Which means I have to divide both of these things by 7. So on this side I'm just left with 1y. 21 divided by 7 is a positive 3. Now this part, you can write one of two different ways. You can either leave it as x over 7, or you could write it as 1/7 times x. Because there's like a 1 in front of that x right there, right? We just don't write it. If you'd rather write the 1, that way you know how much to go up or down, you can. Or you could just leave it as x over 7 as long as you remember there's a 1 there. So now that's in slope-intercept form. The y is alone. What is the y-intercept? 3. So we're going to go to 3 on the y-axis. What's the slope? 1/7. Positive. So it's a really small slope. It's not going to be very steep. So I can go up 1 to the right 7. Or since that's off my graph here, I'm going to go down 1 to the left 7. Because that's like a negative over negative, which is still positive. So it should be a pretty small, steep, uphill line through the y-coordinate of 3. Okay, we had to get it slope-intercept form first before we do anything else.